I'd like to talk a little bit more about how psychology interacts with data visualization. There's a bunch of topics that fit in here. We're going to talk about some Gestalt principles. We're going to talk about some perceptual effects. We've already talked a little bit about perception with colors, but of course, there's much more that we can perceive as humans. I think our goal with visualization is to do what John Tukey says, where the greatest value of a picture is when it forces us to notice what we never expected to see. We'd like to use visualization as a tool to expose us to new things. And an issue with this can be that our brains like to pick up what seems familiar or confirms what we maybe already believe. Of course, we've got our visual attributes from Jacques Bertin, things like points, lines, and areas, shape, size. We now know all about color and texture. And then the idea is, how does this all play out in data visualization? So there's an idea of the Gestalt effect, which is basically that the whole is other than the sum of the parts. So when we look at things, and visualizations in particular, we're not just looking at all the little pieces, we're looking at the sum total, and that might impact what we see. So I've got some ideas from Gestalt theory. One idea is reification, which is that your brain is going to connect things that it believes are connected. So you probably are able to see a triangle here, even though the triangle is not drawn. You probably see a sphere here, even though it's just a bunch of shapes on a flat page. And maybe you see, I sort of imagine the Loch Ness Monster here going under the water and coming back up. I'm not exactly sure what you're supposed to see here, but maybe kind of a rectangle. And if you see something different, let me know what that is. Maybe it's just that, this is wrapping around a pole or something. I'm not sure. But our brain can connect things together that are not connected to form something new. There's also this idea of emergence. So if you look at this image, you probably will begin to be able to see something in the image, even though it's pretty abstract looking at the beginning. So the image that I see is a dog, a Dalmatian, sniffing around on the ground. There's this idea of multistability, which is that you might be able to see two things at once, or swap between two different visions of something. So with the cube, you might be able to see it pop out toward you or recede into the background. I can sort of see it popping out and to the right, and then I can have it going kind of back and to the right. Either way. And then I can see both the vase and the faces, so I can go back and forth between that. We saw that with color as well with the dress. Some people can see the colors of that dress either way. And so these things could affect visualization. There's invariance, which is the idea that most people can move shapes, rotate them in their mind. And so we could see that in A, all of those shapes are the same. It's just different orientations of the same shape. But in B, things are different. In C, they're being warped, but maybe it is the same in some other way. And then in D, they're different textures, but we can sort of see that they're the same. There are certain people who can't manipulate objects in their mind, and so I think this task would be hard for those kinds of people, but most folks can see how an object can be rotated in their brain. So what does this mean for visualization? I got this image from my colleague Jordan Krauser, who is a visual analytics expert. And I think of visual analytics as kind of distinct from data visualization, but maybe it encompasses data visualization and is more general toward all interface design. I'm not sure how Jordan would describe it. But how do these things about invariance and multistability and reification, how do they all connect to these points, lines, and areas that we have in data visualization? There are some more kind of rules of thumb. One is this law of proximity, which is that we interpret objects that are close to each other as a group. So I kind of think this is the reification principle at work. So even though these are not a square, they're just a bunch of circles, they kind of appear as a square to me in my brain, versus this sort of appears like a bunch of little rectangles next to each other. So I'm grouping them together based on their proximity. But then I also will group things that are visually similar to each other as a group. So the color is going to make me see rows here. Again, not that there really is anything there, but that's the way that I interpret it. And there's also the law of closure, which is that if parts of a picture are missing, we fill in that visual gap. So that kind of reminds me of Emergence, where even though not all of the circle is here, in fact, it's just kind of like little specks, I can still see the circle. My brain can fill in the gaps. And this is something that we need to be careful with when we're looking at visualizations, is sometimes our brain fills in the gaps too well. There's a law of symmetry, which is that we perceive objects as being symmetrical. So I could probably see that these things are sort of together, and or maybe there's some center point and things that are arranged around that center point. There's a law of common fate, which is, again, our tendency to group objects that we perceive to be moving in the same direction. So I group these arrows pointing in this direction and these arrows, and maybe I would think about the ones going this way and this way and this way all together, even though they're not right next to each other. There's the law of continuity, and I think this is an interesting one because this is fighting between the law of similarity and then the idea of kind of like reification. So we tend to group objects along the smoothest path. So we might group these objects together because they're along a smooth path, and these objects. But I think that this is sort of fighting with the color, where I can see objects are grouped also by color, and so that might not be the very smoothest path, but the color draws them together for me for that law of similarity. So these don't exist in a vacuum, they interact with one another. So those were some ideas from Gestalt psychology, thinking about how the whole can be more than just the sum of the parts.